Hello, Environmental Science. I'm Mr. S, and this is 5.9, the impacts of mining. So here are the objectives. The main thing to take note of are the learning objectives, which are to describe natural resource extraction through mining. And you can pause the video and read the essential knowledge that I want you to come away with. And describe the ecological and economic impacts of natural resource extraction through mining. So we're going to get an overview of mining today, and then you're going to answer some quiz questions to practice AP style. Okay, so just wanted to start by bringing in the legacy of uranium on Navajo Nation. There's a devastating history where many people in Navajo Nation did not know that how harmful the uranium was when it was being mined for the wars, and there was a lot of contamination. So that's still affecting people today. And this is also in Pueblo communities in New Mexico. So I'm going to have you read some articles about this and become acquainted. So these are some of the main metals that make up the Earth's crust. So just take a second to look at that and pause the video if you'd like. So, okay, here are the vocabulary that comes with mining. And one of the big ones is ore. So, right here, start here. It's concentrated accumulations of minerals from which economically valuable materials can be extracted. So metals, salt, sand. So it would be like part of the mountain that has a lot of it in there. Has different metals and things that need to be extracted. And then metals, of course, you know what they are. They're elements that can conduct electricity, heat, energy, and have other functions. And then a reserve is the known quantity of a resource that can be economically recovered. So how much of the metals do we have? A few other vocabulary words are overburden. And that's when the soil, vegetation, and rocks that are removed to get to an ore deposit below. So that's how much of the earth is moved to get to the resources. And finally, tailings and slag, which are the leftover waste material separated from the valuable metal or mineral within ore, often stored at ponds in the mining site. Okay, so here you have ore, which is the accumulation of minerals that has the economically valuable materials within it. So in this picture, we have iron that can be extracted from this rock, which can then be used to make steel, which is really important for building. Okay, and here is the, and it got cut off a little, but the approximate supplies of metal reserves remaining. So these are the reserves, and how many years we have left of these important metals. So you can see the US only has 2 more years of aluminum, but it can be recycled pretty well, pretty efficiently. But then in the whole planet, we still have 300 years left. And gold, the amount of gold has 30 years left, and then it's just what we have or if we're able to mine from asteroids. And these are tailings. So some of you may have seen this before, but these are all the leftovers materials from the mine. So again, these are the number of years that we have left of various metals. You can see it's really not that long until we run out. And here are more tailings, so large portions of soil and rock that are removed to access ore, and slag is the remaining waste after ore removal. High-grade ore contains a high concentration of the desired material, and low-grade ore contains a lower concentration. And so here are the main mining techniques. You have surface mining, usually used for coal and copper, where you can really blow it off the surface. You don't have to dig. And then there's underground mining, which is mostly used for lead and zinc in the main bigger mines here. So for surface mining, there's strip mining, which is the removal of strips of soil and rock to expose ore. And it's just removing material, extracting the resource, and then returning the mining spoils and tailings to where it came from. So this would be an example of strip mining, where they're just stripping off the top of the earth. And then usually that's coal or sand. And then you have open pit mining, which uses a large visible pit or hole. That's resources still close to the surface, like copper. This is in Montana. It's a really famous and very polluting mine that got most of the copper in the early 50s. And then mountaintop removal, which is the most environmentally devastating form, which is when they literally just blow up the whole mountain. And very common in the southeast, like in West Virginia, environmental sacrifice zones where they blow up the entire region. And then the tailings are deposited in nearby regions. So here's an example of before and after. 30 years between the first and the second picture. Placer mining is looking for minerals and metals in river sediments like diamonds, tantalum, gold. This is the gold rush you think about. And then the other type is subsurface mining. So you can be more than 100 meters below the surface. It's much more expensive. So usually you're going for really high quality, high value products like coal, diamonds, or gold. And they're usually horizontal tunnels, drilled vertical shafts, and elevators. So here's a picture of some types of mines. You'd have the houses and then the inclined shaft that would go down to different levels, or the elevator shaft that got blown down and then you go down there. They're more expensive due to higher insurance and healthcare costs for workers. And the risks are poor ventilation leading to toxic gas exposure, which are hard to detect, mine shaft collapse, injury from falling rock, lung cancer, asbestos, fires, explosions, etc. So it's very dangerous, or it can be. Vertical shaft drill down into the ground. It's often used for coal this way, and it's used more frequently as the surface materials like coal are depleted. And there's a lot of environmental impacts to mining. So air and dust particles, methane and CO2, fossil fuel emissions are huge. You get acid water seepage, and as a result, acid mine drainage, where rainwater leaks into abandoned mine tunnels and mixes with pyrite, forming sulfuric acid. So the water becomes acidic as the wastes leach out, and that kills the aquatic life. You can see the chemical reaction here. Pyrite is exposed during the mining. So the rainwater carries the sulfuric acid into nearby streams or infiltrates groundwater. This lowers the pH, like I said, making toxic metals like mercury and aluminum more soluble in water sources. So that kills all the life in the water. Also, with the mines, you get methane being released, especially from coal mining. And this causes climate change, right? So big greenhouse gas emissions. And then also just particulates. So a lot of people that live near the mines are often people of color, disadvantaged populations, and they tend to have lung issues. So here's soil removal is another environmental issue. With a loss of vegetation that increases erosion. And then you also lose biodiversity, obviously, because you just degrade the environment. So a lot of diseases have been caused by miners, black lung, in Navajo Nation, as you'll learn, a lot of cancers, and in other communities in New Mexico. And last thing, there was mining legislation that allowed companies to take ores from federal lands still in effect today. So there's few provisions for environmental protection in the case of mining. Lots of environmental laws that still need to be made. In 1977, they did Surface Mining Control and Reclamation Act, which has said that the land must be minimally disturbed during coal mining and then reclaimed. The Clean Air Act, Clean Water Act, and the Superfund Act, which we'll get into more, just have laws around what you can and can't do in respect to clean air and clean water. And there's also a lot of laws around the mines having to restore the land that they had been mining on. So there's a lot of work that they usually have to do, but they often can get away with leaving the mine how it is in open pit mines like we have in New Mexico. All right, answer the practice questions, and we'll see you next time.